Welcome, everyone. Today's webinar, we're going to be talking about how to use computer vision AI to improve visual inspection. We've got some very special guests with us today. Let me make sure I'm on the right page to control this. Okay, here we go. To start things off, we've got our very own Dr. Ben Amaba, and he is the VP of Strategic Partnerships here at Clarify. Dr. Jeff Daniels, Director of Automation Center of Excellence for Enterprise Business and Digital Transformation at Lockheed Martin. Dr. Phil LaPlante, Professor of Software and Systems Engineering at Penn State and advisor to NIST. And Dr. Piyush Modi, Global Business Development and Strategy, Industrial Sector for NVIDIA. And then I am Jeff Toffley, no doctor there, Senior Product Marketing Manager here at Clarify. And we're going to give you a introduction to this topic of visual inspection and how AI is used. And with that, I'm going to hand the stage over to Dr. Amaba, and he's going to give you a little background to get us started.
Wonderful. Well, thank you for everybody joining. You're going to learn a lot today because very rarely in our careers are you going to see four experts combine most of the important things in one of the fastest growing industries. You'll hear from Dr. Jeff Daniels. What we've learned over the course of the last 30 to 50 years, that process makes an impact to the success of technology. With AI leading the pack in 2022, as well as machine learning and automation. And they're symbiotic. You can't separate process and technology. Otherwise, it's detrimental. We'll talk to Dr. Phil LaPlante, because what follows process is the people and how they actually take professional responsibility, specifically for computer vision and artificial intelligence. We'll then follow up with Dr. Piyush Modi regarding the platform in artificial intelligence. Again, the process, the professionalism of the people, and the platform brings three of the biggest drivers for success in computer vision and AI. But more importantly, Jeff is going to actually go through a demonstration, because artificial intelligence is no longer science fiction, but science fact. So what I'm going to do is open up to actually introduce each individual person. So as we go through the process, the people, and the platform, you'll understand their expertise, their talent, and what you could obtain. So first with Dr. Jeff Daniels, let me introduce him. He's a head and very well astute in the process. Dr. Jeff Daniels is Director of Automation, Center of Excellence for Enterprise Business and Digital Transformation at Lockheed Martin, employing over 114,000 people worldwide. Dr. Daniels is engaged in not only the research, design, and development, but the integration and sustainment of advanced technology, products, and services. Projects that you'll hear him talk about include the intelligent factory, robotic process automation, DevOps, artificial intelligence, and of course, what they're well known for, their model-based enterprises. Jeff, by the way, was appointed to the University of Maryland at the global campus as a full professor at the Graduate School of Management and Technology, and also serves as a professor at the University of Central Florida, as well as Florida Southern College. He holds a Doctor of Philosophy from Indiana State University, a master's degree in Management of Technology from Rensselaer Polytech, and a bachelor's degree from the University of Florida. He also serves with us as a unit at the USF Board of Directors, as well as an advisory member to the Institute for Industrial and Systems Engineering. So again, Dr. Jeff Daniels will be talking and spearheading the tip of the spear, the process, how it improves technology. Now, Dr. Phil LaPlante has an outstanding record. He's also the professor of software and systems engineering, something that encompasses artificial intelligence and computer vision at Penn State. His research includes computer security, safety critical software systems, AI, and software quality, which you'll be hearing him from. He's actually published over 37 books and over 300 scholarly works, which, by the way, we will have them available after this session, so you can actually see the research of Dr. Jeff Daniels, Dr. Phil LaPlante, and Dr. Modi. Dr. LaPlante holds a BS degree in systems planning and management, a master's degree in electrical engineering, and a PhD in computer science. He, by the way, is also a licensed professional engineer that'll talk about responsibility, transparency, and accountability. We also have Dr. Piyush Modi. Thank you, Dr. Modi, for joining us. He is responsible for the global business development and strategy for the industrial sector at NVIDIA. He's actively engaged with startups, OEM, and system integrators, and plays a pivotal role in research. Over the last 20 years, he held positions such as CTO, Senior Vice President, and Head of Research for companies such as Sentient, GE's Global Research, AT&T, and Bell Labs. He's well known for deep learning, speech recognition, human-computer interaction, again, the people side and the process side, IoT, and voice over IP technologies. Dr. Pios holds a PhD in electrical and computer engineering from Rutgers, an MS in computer science from the University of Tennessee, and a bachelor's in electrical engineering from IIT. So again, then we also, right, to close it off, we have Jeff. Jeff actually is going to close it off to talk about the process, the people, and the platform and how they come together, because seeing is believing. Now, Jeff is also the Senior Product Marketing Manager at Clarify. He talks to the line of business, so he's going to simplify everything for you. He's going to actually show you. He's done product development as well as work with several data scientists. He's passionate about simplifying and elevating technical topics, where he brings over 15 years of experience leading communications, marketing through science, technology, finance, and healthcare industries. So, Jeff, if you would turn the first page, and I'm going to repeat why this is so important to all of us. There's not a single person that's dialed in today where software hasn't affected their health, safety, security, or just their institution. Yet the art of creating it continues to be a dark mystery, which we're going to unravel today, because never in history have we depended so completely on a product that so few know how to make well. And those three drivers are important: the process, the people, and the platform. Because about 5 years ago, Harvard Business Review got the attention of CEOs around the world. And what did they say? And why are we focused here? Over the next decade, AI won't replace managers, but managers who use AI will replace those who don't. So with that, we'll go to the next chart, and I want to introduce you to Dr. Jeff Daniels, who will talk about the tip of the spear and why process is the starting point. Dr. Daniels?
Okay. Hey, Dr. Maba. Let's go to the next chart. Glad to be with you today. I want to highlight some statistics here. When we look at the use of artificial intelligence and data analytics, specifically predictive capabilities, we've been on the path for several years here. And, over the next couple of years, 75% of enterprises will move from the pilot phase to production. And that means they will realize the value of applying AI and machine learning type techniques in a variety of spaces: manufacturing, production operations, sustainment, illumination, supply chain. But they'll get the benefits here of AI and machine learning. Let's go to the next one. So, why does it make a difference? I'm going to flip my phone here. Give me a sec. So, why does it make a difference from an automation perspective? I run Lockheed Martin's Automation Center of Excellence. We've got regression testing capabilities, automated test capabilities. We apply AI for fault detection. We stream back. Dr. Maba mentioned our intelligent factory capability, where we stream back machine telemetry data and feed that into models to gain predictive insights and preventative measures, and our machining, tooling, quality measures. It also helps us close the loop when we apply AI to human-machine interaction and close that digital loop, close that digital thread. And finally, there's opportunities to decrease scrap rates and improve our quality measures through processes and sub-processes. So, you can see the percentage of increases in the value here. And, if you follow the predictions over the next couple of years, we'll move from that pilot phase, which may be early production, into, full realization with a more scalable solution that's AI enabled. Let's go to the next one, please. So when we look at what current challenges do we have, and as we pivot into the future for, an AI-enabled type of enterprise, many Enterprises have 900 plus applications. Your specific organization may have less, it may have more, but most likely it's heterogeneous, meaning that it's got, you've got many different types of applications that you want to integrate, with only a small fraction of those integrated. Perhaps less than a third is what we're seeing in the research. So we know there's more work to do in terms of integration. When we look at data, we know it's out there. It's hard to access sometimes since our systems aren't integrated. The ones that are integrated may not have the data readily normalized in a consumable format to make AI-enabled decisions and feed our models properly. So we often spend a lot of times doing what some may call data wrangling and searching for the right data, normalizing it, getting it in the format to then feed into a model to be accurate. So we spend a lot of time looking for the data that we know is out there, but it's trapped in these systems, these wonderful silos. And finally, even if we get to that point where we have some systems integrated and access a portion of the data, we oftentimes don't know about other automations that have been created or other integrations that may exist. So we find ourselves oftentimes replicating the data across our companies. And I'm sure many of you have experienced that, where a colleague has built a solution that you were unaware of at the time. So let's go to the next one, on our key challenges. I want to highlight, I'll just close on this. If we go back to our research as industrial engineers, Drs. Duran and Deming, find that the vast majority of the time we can find our answer in process, not technology. I'm going to repeat that. We can find our answer in process, not technology. And we're simply finding what's true then when they conducted this research decades ago. It's true today. And oftentimes our processes aren't up to the task of handling today's business. Many of you are facing, rapid changing business environments. You're facing different threats in your segments, different techniques, and our processes aren't adapting as quickly as the world around us is changing. So when we look at the right side here of the joint task framework, we oftentimes jump into that fifth layer of model building. As data scientists and engineers, we want to go build a model. But what we often forget is what Einstein shares here. Spend more time framing the problem, getting the analytics and the data in place to then go execute and build our model. So, following Einstein's principle here, we would spend a bit more time planning and then executing, and not jump right into the model building. I think it's a good lesson for all of us. It'll pay dividends down the road, but the focus on the first couple, 2-3 domains is key here. Okay, Dr. Amaba, back to you. Oh, you're muted, Dr. Amaba.
Thank you, Dr. Downs. This was so important, right? Technology improves 4 to 8%. When you actually do the process, it's 8 to 10%. When you can combine the technology and process, the productivity is 20% or plus. So with that, what's also impending that process is about the people. We've got several articles going out throughout the year, but I want to hand it over to Dr. Phil LaPlante to talk about the people and why professional standards or the minimum standard of care is important before you actually see the computer vision. And by the way, we're also going to place in the demonstration one of the hardest areas, unstructured data. So Phil will talk about, it's easy to deal with structured data, but what happens also as a professional dealing with unstructured data. Dr. LaPlante.
Okay, thank you, Dr. Mama. Next slide, please. So yeah, we're talking about certifying or assuring people, processes, and product. Dr. Daniels talked about processes. I'm going to talk about people. And my perspective is from my work for a long time in professional engineering licensure and certification, but the truth is that there aren't many licensed software engineers in the United States, but there are lots of licensed software engineers, professional engineers in civil, electrical, mechanical, industrial, and in the domains in which these products are going to find, AI products are going to find their way. And particularly for safety critical systems, those are systems that can affect the health, welfare, financial benefit of people. There's a strong overarching obligation on the professional engineers who are responsible to understand the AI that's being used at a number of different levels. And that includes understanding the processes as well. I'll talk about that. Well, I won't talk about that further, but in that second box there on the right hand, it means that the responsible engineer needs to understand, life cycles, needs to understand certification models, need to understand regulatory issues, standards, and so forth. AI and machine learning are becoming prevalent in all engineering disciplines at the university level. Many programs are being developed in AI at the undergraduate level as well as graduate level. But even in other engineering disciplines, you're seeing more AI being incorporated into the curriculum. And so the statistic above there, 34% of engineers involved in the National Society of Professional Engineers have interest and focus on machine learning, the other 26% on software, and I expect these numbers to increase. So next slide, please. We're not just talking about licensed professional engineers, by the way. We're talking about all engineers and the notion of professional responsibility for the work that they do. Now, the US DARPA uses this term assured autonomy. That is the task of assuring that a system's ability to accomplish goals independently or with minimal supervision from human operators in the environments that are complex and unpredictable can be made. And this is particularly important for mission human critical systems. Now, the professional engineer has to worry about, or the engineer has to worry about lots of different qualities relating to AI, and they're almost too numerous to mention. The word cloud there is really just sort of an indicator that there are lots and lots of terms that have been recently invented, others that have been around a long time, some that are overloaded, overused, and so forth. Think terms like trustworthy, ethical, fair, biased, unbiased, and so on. All these are important, and there are lots of different taxonomies that you can explore to get a handle on these things. But the professional engineer really needs to be focused on two overarching categories of qualities: explainability, transparency, and then responsibility, meaning the system is responsible. Next slide, please. So in terms of explainability, it means that the engineer can explain to others, users, stakeholders who are not necessarily technical, who are not necessarily engineers, that they can explain how the system, not necessarily how it works, but why it renders the decisions that it does. Classic example is if it's some sort of autonomous vehicle and there's a vision-based system and a ball rolls in front of the automobile, should that automobile stop or not stop? And, we can get into lots of scenarios where there's a child chasing the ball or not, and so on. But it's incumbent upon the engineers that are working on that system to be able to render an understandable and defensible position as to why the system made that decision. Two approaches are the feature importance-based explanations, where you simply list, okay, this if and this is the then that the system rendered the decision, or a counterfactual explanation. Well, if a child had been in the line of vision a millisecond before, it would have stopped when the ball rolled. A second quality is transparency, and it's kind of related to explainability, but it's the ability to describe in terms that are understandable to the layperson how the algorithms work, and to assure that they are working correctly. And this gets down to the issues of testing. And we don't need to get into the details of the different kinds of white box type testing that could be used. We've written about that in other papers, Ben and I and Jeff, and we can talk about that offline if you need to. And then finally, there's this responsibility that the system, that the engineer has to ensure that the system is fair, unbiased, and trustworthy, so that if it's rendering decisions, it's not somehow rendering those decisions to the detriment of one group or another, or making a decision that's inherently wrong because of the the training that was used. These are all very challenging problems. Next slide, please. And then, of course, the decisions and explanations and design methods that are used by the professional engineer aren't just on a single system. Typically, these systems interact in an ecosystem of other components that may or may not incorporate their own AI, may or may not incorporate software. But whatever the case may be, one can't just sort of isolate their focus on the system that they're responsible for to the neglect of all the others that interact. And so the system, the responsible engineer has to have a systemic overview of all the interacting components in the system. And this is a difficult problem as well. And for each of those interacting components, there also has to be accountability for process, people, and product. The last graphic on the side there is kind of a pitch and an encouragement for folks who are engineers on the line to consider seeking professional licensure because, well, there's financial rewards to it, but also there's a level of expectation and accountability that help to really increase the trust in that type of engineer. Next slide, please. And with that, I'm going to turn it over to Dr. Modi, unless Ben wanted to add something. Thank you.
It's perfect. Dr. Modi's great. And by the way, we're going to choose computer vision for unstructured data. We've been seeing this all around the world. A lot of people in process still make decisions by what we see. Everybody on this call is doing it today. So why did we choose visual inspection for computer vision for the process, the people, and the platform? Is because you can relate to it. It's not only for prevention, it's for isolation as well as remediation. So Dr. Modi, would you take it from here?
Thank you so much for this opportunity to be with my colleagues here and they represent and cover the wide spectrum here. And we talked about people, we talked about process, and we've all been on a quest to do the digital transformation now for more than 10 years. And it's when people, process, and compelling technology, innovations, and platforms come together, that's what happens. And we witness really a very good example of that coming out of pandemic. We are on a growth path in manufacturing. Our PMI is rising 8+% and in 2021, and it's ever increasing in 22 as well. And really what saved us with pandemic was whether it was delivering those PPEs or ventilators, just-in-time manufacturing of that, or getting the vaccine out, was our ability to bring our people, process, and embrace the new technologies. Whether it was computer vision on a factory floor or enabling the remote working for the factory workers or embracing automation with robotics, they all came together. And what we are about to witness is this transformation driven with AI is going to unlock value we've never seen before, almost measurable in trillions of dollars. And there are several proof points already. And adoption of this AI is already yielding us more than 20% increase in production capacity, 4% lowering of material consumption, and 31% increase in OEE in many examples. So what are these examples? Let's look at them. Next slide, please. Yeah. So at NVIDIA, we've been at it. We embrace AI right from the beginning, almost 10 plus years now. And it all started with Vision AI, the first ImageNet competition, as you know. And what it has led us to what you are seeing here, the immersive visualization enabled by NVIDIA's Omniverse, where what you are seeing is a car factory where they make one car every minute, completely gets designed in simulation. All the facilities you see and how the humans work with them is also getting simulated, designed, tested, validated, and put into production in collaboration with human. Even human ergonomics can be studied in this platform, and people are working in this metaverse, a digital replica of factories. The next pillar, what you see is a example from Amazon where their warehouses, where the robots are handling all the material, are getting designed, trained in same Omniverse platform and put to work in automated fashion to move the material. And it's even getting embraced to model the digital twin of most critical assets, mission critical assets we see in industrial. And here's an example from Siemens Energy, where they are able to take multi-physics flows, the chemistry of it in their heat recovery steam generator, simulate that using NVIDIA's Modulus platform, which allows them to do physics-influenced neural networks, to simulate these processes with surrogate models, to predict the corrosion levels, to avoid costly downtimes. And finally, the most exciting part, what we are witnessing now and getting increasingly adopted in all sorts of manufacturing line is visual inspection, video analytics, which is transforming the quality of everything we make, because the first time we now have ability to actually inspect everything that we produce, from French fries to most complex semiconductor wafers, to even paint going on a car, to the linen, and fast-moving lines like where we make our CPG, consumer product goods like beer cans. They are all getting inspected with Vision AI. And this is, again, a testimonial to kind of productivity we are unlocking in terms of increased production, in terms of increased better usage of the workspaces, or removing those quality escapes by removing those false alarms, and really taking out tedious repetitive tasks and unburdening humans to focus on more important stuff. What does it enable this? And this is our investment has led to, next slide, please, a platform. In NVIDIA terms, the platform is really about complete full stack. And everywhere where we saw the opportunity to bring our learnings together and help our ecosystem to deliver on time to value, we have invested. So at the bottom layer, what you see is our complete collection of CPU, GPUs, and DPUs coming together from edge to the data center to the cloud, enabling various systems, working with our partners in OEM community. We call it NVIDIA certified systems, enabled with NVIDIA software stack, which is, think of it as AI operating system. We call it NVIDIA AI, and enabling these core capabilities to enable collaboration for data scientists, improving their productivity for designers, and giving them assets like pre-trained models with the testimonial on what compute capacity they need, what workflows they need, so they can design entire system, not just MVPs. For Vision AI, we have a platform we call Metropolis, and for robotics and automation, it's Isaac. But it happens, all this comes together when our ISVs like Clarify adopt it to create innovative solutions and applications, just like I demonstrated, to really put it out there in practice. So really the key message here is people, process, and platform, they come together when you give them the right tools, motivational use cases, outcome-driven approach to delivery. And this is where, if we go to the next slide, our entire ecosystem is pulling out there for all the manufacturers to unlock that trillion-dollar economy we want to kind of create. And as you can see, it's a team sport from our systems providers in the box you see at the bottom, the cloud service provider. Every solution these days has to be servitized model, cloud native, so that it can be managed, deployed, and serviced through its entire life cycle, not just a POC. And then there is a very critical players who are integrators who understand where all our manufacturers, the industrial customers are, and what matters to them in their playbook. And this is where our system integrator, solution integrator comes to play. But really, the real magic is the hard work done by ISVs. Many of them are startups who are pulling it together and highly focused on specific use cases. And they even have practice, our service delivery partners, where they come, work with our customers, do the ideation process, map out the entire playbook, and then work according to your priorities, design those MVPs to success. So with that, let me give you a testimonial. Let's invite Clarify to tell us about what that journey looks like for them on meeting customer expectations.
All right, I think I'll take it from there. Ben, any comments?
This is great. Dr. Modi, thank you. Again, process, people, platform. Now you're going to see the demonstration. Again, AI is no longer science fiction, but science fact. So Jeff, take it away.
All righty. So let's dive in here and take a look at some specific use cases and take a look at the data that one might be working with in these visual inspection cases. And to be successful here, you have to have the right processes in place. You have to have the right people in place, and those people need access to the correct information. And then you need the infrastructure that makes it all possible. And NVIDIA is hard at work building both the chips and then the sort of the network and infrastructure that makes it all makes those chips useful. And then here at Clarify, we are here to work with the actual end user in developing solutions. And we're going to take a look at some use cases. And we're specifically, of course, today talking about visual inspection. And so we're going to take a look at images. We're going to take a look at some of the reasons why you'd want to use images as an input in your system. You know, what is good about images versus other sources of data. To begin with, visual inspection, predictive maintenance is also another subcategory of visual inspection and is an important part of the story. Manufacturers, heavy equipment maintainers, heavy industry, transportation, there is a promised land ahead where we're going to be able to better predict when maintenance is needed. And we're going to be able to get ahead both in terms of providing the supply. You know, when a part needs to be changed out, you can order it ahead of time and have it ready when it's needed. And we can also provide more precise estimates about maintenance by taking us out of the world of just using 3 years and 36,000 miles like you might see on your car, and instead actually be able to inspect the actual current state of a given part and make an estimate about how long that specific part being used in a specific environment for specific purposes is going to last. So we're moving towards these sort of solutions. Visual inspection is popular in health, safety, security environments, but in particular, we have seen strong demand in transportation and have been in contact with a lot of airlines. It's critical that a plane be safe. And so there's a lot of work that currently goes into visually inspecting aircraft, looking for damage, looking for potential risks. And this takes typically 2 full-time employees that are highly trained in this domain, 24 hours. And they spend a lot of time going over every inch of an aircraft. And this is exactly the type of case where automated computer visual inspection can speed up the process and reduce risk because the computer does not get tired. So the computer can endlessly scan planes all day long, and it will always produce the same predictable results based on the model that you have. Visual inspection can take a look at the entire system. So we're going to be able to take a look at anything where you had a person going in and using their judgment, we would be based on visual inspection, you would be able to automate and use as part of a computerized visual inspection system. Foreign object detection is another part of the there's another aspect that's very important to airlines, and that's just maintaining the safety of the actual airfield. It just so happens that a lot of damage happens to these planes when they're on the ground because there are various objects that can find their way onto the tarmac, and with the powerful section of the jet engines, these things can get sucked up into the jet engines and cause damage. So how does Clarify help companies build these kind of solutions? Well, here's a real high-level overview of what we do. So customer will provide input data. In this case, we're talking about data in the form of images or video, and video is just a collection of images in a time series. So video really is very similar in many ways to looking at individual images. We are able to label that data with our Scribe platform, and that is critical when you want to create a new model. You're going to have to provide examples to your AI model in the form of labeled data, and that's where Scribe comes in handy. Search, visual search is really easy with a platform like Clarify, where you're going to be able to work with your data intuitively. You're going to be able to work with images in a similar way that you search for data when you go on the web and you're Googling things. And so we think that that's a really useful part of what we do. Enlight is our training suite, and it just makes it dead simple to get new models trained. We provide a lot of pre-built solutions, but then we also provide the building blocks for customized solutions. And we're going to take a look at that here in our demo. And then Armada, it takes care of all the complicated ML ops that happens in the background. So it is one thing to have a data scientist prepare his model and his or her model and get it up and running and run predictions and have the model perform well. But it's an entirely different project altogether to get this thing running at a production scale, create an adaptable system that can run one model today and run another one 3 days from now and run 100 models next year. And that's what Armada is there to take care of for you. And then Mesh, it provides a simple visual workflow editor where you can factor your business logic in at a real base level. So as you're making model predictions, you're going to be able to say, if the prediction is of this type and it's of this level of confidence, then do this or that. And Mesh provides a nice interface for that, where you can branch various decisions and perform complex business logic. The continuous model improvement loop is also another aspect of the platform that's worth calling out. So learning being the key word here. So these systems are very much like us. They learn from experience. And so typically the way it works in the AI biz is you start with one set of data, and it may not be all the data you ever wanted. It may be data taken from a slightly different context. It may be a set of data that's sort of good enough to get you started, but doesn't quite get you to the accuracy levels that you will really want to achieve so that you can fully automate your processes. Well, it's by allowing for a feedback loop in the learning process, where you start with one model that's pretty good, and you set it into production, have it doing good work for you, but have it learn over time as it makes mistakes. You're going to include a human in the loop to help train it up, and it's through this sort of process that you'll be able to iterate and develop a highly accurate model and fully automate processes. So with that, let me just hop on. I'm going to shift this presentation over to a different screen so we can just give a sense of what this looks like in practice, right? So, okay. Can everybody see my screen again here?
We see the PowerPoint, but not the demonstration screen. There we go.
There we go. Okay, so let's start with a really simple example. Okay, so this is just a binary choice being made. Is this part that's being produced on the manufacturing line defective, or is it okay? You can see here that we've loaded in several images. You could set up a camera on your line, set it in a fixed position, and take a picture of these parts as they come out of the line, one after another, and inspect each and every part without stopping production, right? So the enormous advantages there. And if we click into an example, let's see what actually happens. So we've trained up this model, and we did it with very few examples. We had 78 defective and 108 okay. And from there, we were able to train a new model that makes accurate predictions. Here we have an 81% confidence score, and it automatically labeled this input as being okay. Okay, so there's an example of the input that was sent to clarify is the image, what the customer gets back is labeled data and a confidence and a prediction that is saying that this is indeed okay, along with the confidence score. So this confidence score, this threshold is really critical in a lot of these processes. A lot of times you're going to say, if it's above 80%, go ahead and label it. And if it's above 70%, then you send it to your human in the loop for review so you can iteratively improve your model. Okay, so that's just a quick, simple example. Here's a defective part. It looks defective to me, and you can see the model also predicts it that way, and then it's been labeled that way. Okay, so there's a simple example. Here's a slightly more complex example where we have multiple classes, and this is looking at metal surfaces on a production line. So you're able to identify the type of issue that might be present. The model has been trained up and the data has been labeled, and then using the Clarify platform, you can just click on a keyword and go to any data that's been labeled automatically. You can see two different classes at the same time. You can mix and match and work with your data. Again, you can pop in here. Take a look at the predictions, and here we see that it's clearly patches. So just to give you a sense of how that would work. And then another thing that we might want to call attention to here is the visual search capability. So without even going through the stage of naming things and training up a new model and labeling it, whenever you upload data into the Clarify system, it's ready for visual search. So you might just say, you uploaded a bunch of data, hit search here, you're going to get a tiny thumbnail of the image in question, and it just makes it really easy to sort and filter your data. You could then go through and label the data yourself with whatever keywords you'd like to name. And so I hope we're getting a sense of why these are visual tasks, right? These are very much like the visual qualities of the materials being inspected. But what I want to do is this final example is really illustrate what's different about working with visual data, is that these two examples are in very controlled environments. These are images taken at the same distance and similar lighting, and all the data looks very homogeneous. But out in the world, there's going to be a lot of processes that are not so friendly. And where AI for images comes in handy, and why visual inspection is so special, is that it is really adaptable. So here we have pictures of train tracks out in the wild, incredibly diverse set of issues at play, different lighting, different times of day, different environments. And this also is very much an appropriate case for AI automation. And here you can see we have simple binary classifier again, defective and non-defective. And we're able to load in these examples and have trained up the model with a few more. What was it, 300 images on this one?
Hello,
And,
Jeff.
yes,
Jeff is Kathleen. I'm just, I'm interceding for Judy, who on chat said, can images be bulk labeled?
Images can be bulk labeled. And in fact, So there's different ways, there's different senses where that might be the case. So you might have your AI system bulk label your images as they come in. You might say anything above 90% automatically label it as defective or non-defective. Or Clarify makes these kind of tasks very easy. Say you want to upload some additional images, and what you can do is actually add your labels at upload time. So there's going to be times when you know, oh, I've got this batch that I want to load up, and I know that this is already, I already know that this is defective images. You can actually assign that at upload time, and that makes it extra convenient, which is actually what I did in this case. That is our demo. Those are the main points that I wanted to drive home. So we know you need to understand your process. We know your people need to have the resources and education and background and certifications necessary to do their work. And then, of course, we need this underlying technical hardware and infrastructure to make it all possible. And then with a solution like Clarify, we're bringing this. Sometimes people talk about democratizing AI, but really it's just about making AI available to everyone. And here we're taking a look at specifically these visual inspection use cases, but actually we can work with any kind of issue where there's a visually distinct topic at hand. So with that, I do want to be sure we have time to address questions here at the end of our presentation. So any questions from the audience? Perhaps I'll just check in with Eric here to see if we have any questions?
The labeling one is the only one I saw, and we answered that one.
All right.
I don't think we have a bunch of shy folks. Hi, I'm Kathleen. We really brought together this whole panel of experts to really answer any of the questions that you have. This notion of AI advancing a lot of manual tasks and embracing low code, no code types of models and platforms to accelerate work is something we really felt we wanted to bring forward. Would love to take any questions that you might have. Bart has raised his hand. I will open the queue. Go ahead, Bart.
Okay, I'm a mechanical engineer. I'm a PE, and I'm interested in this. However, I don't speak double E. Double E is a wonderful language that I was not graced to learn upon childhood. It is speaking in tongues. So I am not an electrical engineer. I'm not a computer person. I do a lot of simulations, though. I'm more on the FEA side and the CFD and all these other letters. My question is, given you have people like me who are project engineers, allegedly responsible adults doing these things, how hard can you walk me through really quick if I came to, let's say, Clarify and said, I have a bunch of video, or I need to get some information classified, I need to get something sorted, and I haven't taken the data yet, so I haven't decided to run drones or run cameras or what have you. How would I go? How would I make this actually something I can wrap my hands around and use?
Eric, would you mind taking that?
It's a good question. The out-of-the-box functionality of the platform is you can run videos through our out-of-the-box models to get insights, like what is in the video, what items, do classification of them. The real power of the platform, however, is once we have data to be able to start looking at, okay, what do we have, what models or insights do we want to get from it? And then the platform can very easily be used to either classify or detect, like Jeff showed in the demo of how you can build your own custom model to get your own insights out of your data.
So if I came to you with, and again, let's assume I was being proactive. I came to you. If I came to you, I want to get this kind of data field covered, let's say an accident site. Let's pick a better one. I want to look at municipal solid waste, and I'm looking for specific sizes and shapes of items that in my head will turn into something I want to recycle. If I came to Clarify and I said, here's what I want visually to detect, you guys would work with me to come up with how to gather the data and how to parameterize the target. Is that correct?
Correct. Yes, we have that. That's what our science team and data wrangler team does for a living, is help our customers, once they know what they're looking for, what problem they're trying to solve, come up with the right data collection strategy and labeling strategy to build the taxonomy and the approach to solving that problem.
Okay, thank you very much.
Yeah, so in case this basic level of it didn't get across, so these you're going to have to teach your AI to learn about the world, or to understand the world in a way that's useful to use. So if you're looking at municipal waste, this is your domain that you're going to be working in, and you're going to be maybe looking for, I don't know, plastic recyclables in municipal waste. And so you're going to have to get a bunch of examples of that. So this could be, maybe you could run a video or something over an area, and then you're going to have to label that data up. And Scribe is the tool that we offer for data labeling, which is a self-service tool, or we can take care of the labeling for you. And then you would go over to the Enlight stage, click train. It's literally just a button you press, and you click train, and then you'll have a new model trained up that will learn based on the examples you provided, so that when you hand it then a new image, it can identify plastic bottles in the waste. And then there was just a general question about getting a recording of the video, and we do share a recording of the video with all participants. We'll shoot you an email tomorrow. All right, any other questions come up here that I didn't see?
Jeff, while we're looking for questions, again, Jeffrey can provide some of the research from Dr. Daniels and Dr. LaPlante and Dr. Modi, which we've been looking at. But more importantly, we're going to continue this cadence of sharing this information. I think, Dr. LaPlante, we actually have a conference, international workshop in Charlotte, North Carolina. You might want to mention that, Dr. LaPlante. We will also be at the Professional Engineering Conference talking. Bart, thank you very much for joining us there. And we'll be in Atlanta for the Data Sciences Conference, as well as Augusta for the conference on the Army using computer vision. But Dr. LaPlante, did you want to mention?
Yes. Yeah, thank you. On October 31st in Charlotte, North Carolina, actually at the University of North Carolina, Charlotte, we will be holding our first IEEE sponsored workshop on assured autonomy, AI, and machine learning with the fancy acronym WHAM. We'll provide a link to the RFP for that event if we can. And folks are certainly welcome to submit articles if they have interest in submitting a paper or presenting a paper there, or attending. And we'll be covering a lot of the issues of machine learning, assurance, and trustworthiness, transparency, explainability, and so on. So thank you.
Yeah, and for further reading, I would encourage everyone to take a look at our distinguished guests. Really have an enormous list of publications that they have participated in, but just some highlights I'll mention is Dr. LaPlante and Dr. Ambaba wrote a paper called The Internet of Things Grows Artificial Intelligence and Data Sciences. Dr. Amaba and Dr. Daniels and others worked on a paper called A Framework for Best Practices for Delivering Successful Artificial Intelligence Projects, a case study demonstration. And finally, I'll just mention Dr. LaPlante and Dr. Amaba worked on a paper that you can find called Artificial Intelligence in Critical Infrastructure Systems.
I will also mention, it's Kathleen, anyone that would like to discuss your specific business initiatives one-on-one and not in this public forum, please feel free to reach out to Eric Johansson directly. He is our lead customer success manager and very technically oriented and can help you consider the approaches that you might take to visual inspection or other AI related problems your organization is wanting to explore.
Great. Eric, would Eric put his email in the chat for the audience members? Oh, Kathleen might have done it already. Thank you, Kathleen.
I'll do it.
Yeah, you're typing faster than I am. So.
Great. Well, hey, well, thanks so much for joining us, everybody. Let me just put Eric's email up here real quick as well. Visual as well, in case people are not able to see the chat.
I think I got a typo there, guys. Sorry. Eric, I might type fast, but you know your name better than I do.
Well, yeah, that's Jeff, you got the mistake in your.
Oh, I have the mistaken one.
There's an E missing.
There we go. There we go. There we go. The last one's right. The last one's right from Kathleen. Or you can find him on LinkedIn. If we messed up the emails yet again, you could find him on LinkedIn at Clarify.
There we have it, everybody. Okay. So, oops, let's go back there. So thank you so much for joining us, and please do follow up with Eric with any specific questions, and we are more than happy to help out. That's what we do all day long, and we look forward to seeing you at our next event.